This evening, I'm going to talk about the need for us, particularly as developers, to be time travelers when it comes to accessibility, and in particular, accessibility mechanics. We've got nearly 20 years of accessibility on the web behind us, and there are things from the past, the present, that we can draw on and need to draw on, and also things that are coming in the future that we need to be aware of, we need to feed into, add our opinions and our comments as they start to take shape, because almost certainly they will become part of our future in the products that we build. Browsers will be a familiar thing to all of you, I'm sure, particularly for the moment these four browser engines, WebKit, Edge HTML, Chromium and Gecko, that are mostly represented in Firefox, Chrome, Edge browser and Safari browser. I say for the moment because if you haven't heard, Microsoft has just announced it's going to stop developing Edge HTML and switch over the Edge browser to using the Chromium engine. So we're going to lose a quarter of our browser engine ecosystem, which is somewhat worrying for those of us who lived through this website was designed for IE6, best viewed at 480 pixels. But anyway, I digress, that's not a topic for today. But browsers have a very close relationship with assistive technologies, and in particular, screen readers. Again, if you're not familiar, a screen reader is a piece of software that sits on pretty much every operating system available now. On Windows, there's the proprietary screen reader JAWS. There's also an open source free screen reader called NVDA, and a free integrated screen reader called Narrator. On Apple products, both iOS and macOS, you have an integrated free screen reader called VoiceOver. On Linux, there is another free open source screen reader called Orca. And also on Android, there is the TalkBack screen reader. So there's good choice when it comes to screen readers. The reason I want to talk to you about this particular relationship between these two applications, the screen reader and the browser, is because it's absolutely critical to the accessibility of content on the web for screen reader users. Oops, sorry, here we go. So in the past, let's start our journey there. In the late 1990s, there were only screen readers for Windows. They were all proprietary. There was a screen reader for the Mac operating system, but they stopped producing it. It was a third-party application. They stopped producing it in about 1997. So for the best part of a decade, Windows was the only choice for screen reader users. And what used to happen when we loaded an HTML document into the browser is that the browser would take the document and it would go off and it would parse the HTML. It would create the document object model, the DOM, that we are aware of as scripters and coders. It would also create the graphical view of the HTML, the bits we can see on screen. It would apply some browser-specific styling to give some of those things like headings and form fields a visual representation. And it would provide interactivity where that was necessary. So you can type into edit fields, you can press buttons, all of those kind of things. The screen reader used to come along and do exactly the same thing, but completely separately. So it would pass the HTML document and it would create its own virtual model or virtual buffer of the page. And the browser and the screen reader did this without really having anything to do with each other. So we had two applications taking the HTML and creating representations of it suited to their particular audiences. Now, it doesn't take a genius to figure out that's not the most efficient way to be doing things, and it's also not the best way to be doing things, because when two different people take the same thing and look at it with their own perspectives or their own opinions, what generally happens is that you end up with two largely separate interpretations of the thing, and that's not very useful from anybody's point of view. So again, if you're not familiar with a screen reader, what this enabled people to do from the sort of 1990s onwards with the web was to read text a little bit like this.
Heading level 1 using the ARIA current attribute posted in link code things on January 14, 2017. It is common on the web for the current thing in a collection to be highlighted visually, but providing an alternative for screen reader users has often involved something of a hack. The link ARIA current attribute is intended to solve this problem.
So it was great because it was possible to access content, but it was a little bit laborious because reading web pages was very much like reading a text document. You had to start at the top of the page and read until you found the bit that you were really interested in, and then, well, keep reading. This gave rise, in part, to the idea that assistive technology users and screen reader users in particular need longer to interact with web pages and other applications. That might have been true back in the day. It's most certainly not true now. And part of it is because we don't tend to listen at the speed most other people can find a screen reader intelligible at. This is my screen reader reading that same clip, for example.
Heading level 1 using the ARIA current attribute posted in link code things on January 14th, 2017. It is common on the web for the current thing in a collection to be highlighted visually, but providing an alternative for screen reader users has often involved something of a hack. The link ARIA current attribute is intended to solve this problem. Heading level 2 common.
So, like most other human beings, screen reader users are not known for their patience. We dash through content pretty much like sighted people scan through it visually. We have ways and means of speeding up the whole process. By the time we get to the early 2000s, things had changed quite radically in the relationship between browsers and screen readers. The browsers had implemented support for platform accessibility APIs, and that meant that screen readers could ask the browser for accessibility information about the content. So the browser really took on the job of doing all the heavy lifting, and the screen reader just had to come along and say to the browser, now you've taken that HTML and you've done your DOM representation and your graphical representation, tell me what you know about the accessibility representation of this content. And that structure is known as the accessibility tree. By the mid-2000s, we also had voiceover on the screen on the scene from Apple. So again, there was more choice here as well with this change in environment for the relationship between the two pieces of software. Like browsers and screen readers, there are platform accessibility APIs available on every operating system. In the desktop arena, there are 3 platform accessibility APIs on Windows. There's one for macOS, another for iOS, another for Linux, and if you look at the mobile space, Android has its own too. These are not APIs as we recognize them as developers. They are only usable by assistive technology applications. So we can't JavaScript them, we can't use them to ask the browser for accessibility information. Only an assistive technology like a screen reader can do that. And what happens is that when HTML is loaded into the browser creates its accessibility tree of all the content. The screen reader comes along and sends a message through the platform accessibility API and says, hey, this element on the page, what can you tell me about it? What purpose does it have? How do I refer to it? Does it have a name? What state is it in? Tell me all the information. So we see things like this becoming possible. If we take the HTML5 main element, it's there to mark up the main content area of the page. And in the accessibility tree, we will see that it has a role of main. That's its purpose. It's to mark up the main area. Beyond that, it doesn't have much accessibility information available about it. But a screen reader will ask the browser for the information and use that to say something like this to the user.
Main region.
Main region. So as someone who can't see they're at the start of the main content area, the screen reader just tells them that's where they are. It's also a useful navigational hook. Some screen readers let you jump straight to the start of the main element if it's present on a page. And so you've got a quick way of getting straight to the meat of the page. The nav element is another example. If we look in the accessibility tree, it has a role of navigation. And again, the screen reader can use that information.
Navigation region.
It becomes very simple. And again, you can navigate to navigation regions as well as the main region. So this not only gives you an indication as to what part of the page you're on and what its purpose is, it also gives you a quick way to navigate between high-level chunks on every page. The equivalent, if you like, of glancing at a page as a whole and taking in its kind of relative different sections. The browser also does useful things with things like lists. So we take an ordered list and 3 steps inside it. The browser will not only make the information available that this thing has a role of list and the things inside it have roles of list items, it'll count up the number of list items inside the OL element and make that information available to the screen reader when it asks to.
List of 3 items. 1 do this. 2 do that. 3 do something else. List end.
And all this is just provided courtesy of the browser because of the information in the HTML. It works for headings. So for example, in this case, we can see that the H1 element has a role of heading. It also has an additional property that's made available. It's level, in this case, a level 1 heading.
Heading level 1.
And that information gets used by screen readers to know something of the hierarchy of content on the page. Heading level 2, followed by heading level 3, gives you a sense that there's a main section on the page, followed by a subsection, and inside it, further subsections again. So really useful information if you can't take the page in at a glance. It also works on all kinds of form fields. So for example, with a checkbox, it can tell you based on the type what kind of form field it is, and also based on its checked attribute state, what state it's in. So there's lots of accessibility information made available about it. Lastly, if you associate the form field with a label using the ID and 4 attributes with the same value, that gives the form field an accessible name. It tells the screen reader how to refer to this checkbox when it's telling the user what kind of thing they're dealing with. So we get something like this.
I live in the UK, checkbox not checked. Checked.
So I live in the UK was the label provided through the label element. That's how the screen reader knew how to refer to this particular checkbox. And we understood when someone had come along and checked it because its state had changed. The browser made that information available to the screen reader, and the screen reader told the user. So it all connects together pretty efficiently under the hood. We can take a button element as a good example of this. If we look at it, it has a role of button. In this particular case, we'll assume it's a play button, perhaps for a media player of some description. So the text inside the button gives it an accessible name. It tells the screen reader how to refer to this particular button. And that means that when we interact with it, the screen reader gets some information.
Play button.
So it took the accessible name and said that it was a button, and the user's quite well aware that they're dealing with a button. For those of you looking at that slide, you might have noticed that there is a missing piece of the puzzle though. That button was toggled while the video was playing, but there was no announcement of that by the screen reader. That is something we can fix though, which brings us on to the present and our current situation. We have come into an era now in the past perhaps 10 years where we create custom UI controls and components. We take divs and spans mostly as building blocks, and we try to create things that don't exist in HTML. Tabs and tab panels are a probably really easy example of something that there are no HTML elements to use, so we have to create them for ourselves using JavaScript for functionality, CSS for styles, but we're going to be missing some accessibility information. This is also the case because JavaScript frameworks, they all, unfortunately, have a bit of a nasty tendency to decide that a span is far better than an anchor element, even when the span itself is going to be a link. Don't get me started on that, but the reality of it is that we have to deal with these situations. The accessibility problem is that div and span elements are effectively meaningless in accessibility terms. They don't have a particular role, they don't have a particular state, you can't interact with them, the browser doesn't provide any form of interaction, mouse support, keyboard support, none of it. So even though we could take some divs and spans and we could style them to look like, say, a 2-button toolbar with a bold and an italic button in it, we could use JavaScript to make it function like a toolbar. When a screen reader comes across this collection of divs and spans, unfortunately all they're going to hear is this.
Bold. Italic.
Just 2 pieces of plain text, because there's no accessibility information anywhere near this particular custom-made component. The good news is that we can do something about that. We can use ARIA, Accessible Rich Internet Applications, to polyfill some of the missing accessibility information. ARIA 1.1 is the current version. It was released earlier this year. They're already working at W3C on ARIA 1.2. But as it stands, there are more than 70 different roles that you can apply to elements like divs and spans. You use the role equals attribute, and then you choose a value depending on what accessibility role you want to fill in. There are lots and lots of them. Pretty much every component you can think of has a role value in ARIA. Buttons, checkboxes, radios, radio buttons, radio groups, sliders, toolbars, progress bars, trees, grids, tables, and so on. Like I say, 70-odd different values. So if you're using a div and a span to pretend to be something else, then you need to use the role attribute to fill in that missing accessibility information. There are also 45 ARIA prefixed attributes, aria-something. And these are the attributes you can use to fill in things like missing property information. So ARIA level, if you were faking a heading, for example, with a value of 1, 2, 3, 4, 5, 6. You can also use these properties to inform about the state of something. So ARIA expanded, if you're building a disclosure widget and you want to tell a screen reader user when it's open or closed, for example. There are lots of these that can be used to, again, fill in more of the accessibility blanks. So if we take this truly appalling example on screen of a span that is about to pretend it's a button, so we just have a span, and we'll take the play button example that we looked at before. Right now, as this stands, as I say, no accessibility information in a span element. It's inert, you can't interact with it, you can't focus on it with a keyboard because the browser doesn't think it has to do anything with a span element. It can just sit there and sort of look good, I guess. So we can use the role attribute with a value of button on the span, and in the accessibility tree that the browser creates when it sees this HTML, screen readers, when they ask, will now find out that this thing is a button. Still won't behave like a button. We can style it to look like a button, but at the moment it's still just a span pretending in the accessibility tree to be a button. We can use tabindex with 0 to start fixing some of the keyboard support. Tabindex 0 will make it focusable, so someone who's using a keyboard can tab onto it now, which is a good first step when you actually want to do something with a button. This also means that speech recognition tools will be able to focus on it with much the same result. They'll be able to actually start interacting with the button. We do need to provide the interaction. Mouse interaction is usually the first thing people think about, so we can just add a mouse click event listener. But we also need to make sure that, like a native button, someone who uses a keyboard can hit the space or enter keys to make the thing active. So we listen out for the key codes 13 and 32 in some JavaScript, and when we detect either of those being pressed, we get the button to go ahead and do whatever it is it's supposed to do in life. Oops, sorry. So then we end up with a button that, to all intents and purposes, looks and behaves and reacts more or less like the native button.
Play button.
We're still missing that important piece of information, though. How do we let the screen reader user know when they've actually pressed the button or not? We use one of the ARIA prefixed attributes, and it won't come as much of a surprise, I'm sure, to know that it's aria-pressed. We can set that initially to false, which will do several things. It will change the role of the button to toggle button. So as soon as a screen reader asks for information about this now, they'll be told it's a toggle button rather than a standard button. And its current state will be in a not pressed state. We can then add some functionality in, and when someone now hits the button, what we'll do is we will change the value of the aria-pressed attribute. We'll change it from false to true, i.e. we change the button state from not pressed to pressed. So in the accessibility tree, this information is now available for a screen reader to go ahead and grab. We can do something even more useful. This is a tip I picked up from my friend and colleague Hayden Pickering, which is to tie the visual style of the button to the states of the aria-pressed attribute. So only when the aria-pressed attribute changes from false to true do we change the CSS that changes the visual appearance of the button to look as though the button has been pressed. It's not a showstopper, it's not even really necessary, but it's a really useful way of making sure that your accessibility is working. Because if your accessibility isn't working and you've tied your visuals to it, you'll know about it sure enough, because when someone comes along and presses or clicks on the button, the visuals won't change as you expect them to. And you know the first place to go looking for a problem is probably in your accessibility code. So it's a helpful debugging tool and a slight simplification of the code, if you like. It is worth noting, oh, hang on, no, wait, sorry, and then we can see a demo, sorry, yes.
Play toggle button not pressed. Pressed. Not pressed.
And so now we've got all the information we need. A screen reader user asked the browser for information about the button. They were told it's a toggle button called play. When they hit the button, they were told it was pressed, and when they hit it again, told it was not pressed. And so suddenly we've joined up all the dots to create a much more complete experience for someone using a screen reader. I will point out, though, that starting off with a span as a button is a really bad idea. So just using the button element with the aria-pressed attribute on it is a far safer way to go about it. And if you're a little bit lazy like me as a developer, it's a much better way to go about it, because you don't need to add in all that extra JavaScript. You don't need to add in all the extra attributes for tabindex and the role and other bits and pieces. So it simplifies your code, and it simplifies your testing, because the fewer moving parts that you've got in your code, the less likely things are to break when you start testing them. We're also in the present at the time now where we're starting to see custom elements appear on the scene. I was talking to the team at British Gas very recently, and they've just relaunched their homepage, and it entirely consists of custom elements and web components. If you're not familiar with this idea, it's that we can take existing HTML elements and we can change or extend them, or even completely invent new ones. So we could, for example, take our button example, extend the HTML button element in HTML and create a new element called toggle-button. Custom elements always have to have a hyphen or a dash in the middle of the name somewhere to distinguish them from actual, quote, proper HTML elements, unquote. So in this case, we'll create a toggle button that wherever we use it will create the button that we've just seen, our toggle button for our media device, for example. We just create the custom element, and inside the constructor we set things up. Custom elements use something called a shadow root, and that's because custom elements work very much like, elements like the video element. So we just use video, source equals something, close the video element. Yet when that's represented on the screen, there's a whole bunch of buttons and sliders that the browser makes visually appear and presents them on screen for use. If you inspect the code, if you look at the DOM, you won't find any of those buttons and sliders and other bits and pieces. And that's because they're all contained in something known as the shadow DOM. It's all terribly Jedi, but that's the name they give to it. It's things that you can interact with, things that are displayed on screen, but when you inspect the code underneath, they're apparently not there. And custom elements work in very much the same way. So we use a shadow root as the starting point for our element. And then basically, in this particular example, I've just thrown all the code in from the previous example for our toggle button. I've used the worst of the examples, added in all the tab index and ARIA attributes and other bits and pieces. So the code is exactly the same. It's just tucked inside a custom element constructor. What this means is now, as a developer, I could go to my page and write open toggle -button, put play in the middle of it, and then close toggle button. And that's all I would need to do in the HTML. It's very, very simple and very, very clean. Now, this is just a button example, but you can imagine doing something like this, say, for a set of tab panels. So instead of having to use divs and spans or lists and section elements and a whole bunch of ARIA and other bits and pieces of attributes, you could actually simplify this to create, say, a tab group element that contained tab elements that were associated with panel elements, for example. So it's a very neat way of simplifying your code. And if we do this, when we play this and we use our toggle button, again, the experience is remarkably familiar.
Play toggle button not pressed. Pressed. Not pressed.
There is one slight catch with this, though. And that's when we currently go and look at our toggle button in the code. When I said that you'd see most things wouldn't be there, they're all in the shadow DOM, there is one exception. At the moment, custom elements leak accessibility. So where we've applied the aria-pressed attribute inside our custom element, when we use the toggle button element in our code, the aria-pressed attribute is still being applied there. And so, again, with one attribute, that's not really the end of the world. But when it comes to adding a lot of accessibility attributes into your custom element, it starts to get very untidy. In a custom element, everything otherwise is encapsulated. All the styles are encapsulated, so they don't leak out. All the functionality is encapsulated, so they don't leak out. But right now, accessibility does sort of spill out sideways into the main document that you use your custom element in. And that's not ideal, especially for engineers who tend to like things to be neat and tidy. Ooh. So that brings us to the future. There are people thinking about how to solve this leaky accessibility problem in web components and custom elements, and also ways that we can, as developers, use accessibility and access the accessibility tree in the browser more easily. And the answer is in something called the Accessibility Object Model, or AOM. It's being developed by people from Mozilla and Google and Apple. And it has 4 phases. And if it comes into being properly, it will be a JavaScript API that we can use as developers to ask the browser to give up its accessibility information. In other words, we'll be able to talk to the accessibility tree in the browser just like the assistive technologies can. I will say if it comes to fruition. The team working on this already came up with version 1 and it introduced something called an accessibility node. They then scrapped that because they decided it wasn't really a sustainable way to do things. So they're currently right back at the drawing boards. So as of this moment, there is no support for anything in the AOM, but they're very, very committed to working on it, which is why I want to talk to you about it today, because this very much comes into the category of things that we all now need to be feeding into to make sure that they get it right when they do. So phase 1A of the AOM will do something very simple and very useful. It will enable us to use element and attribute reflection when we're applying accessibility attributes. So at the moment, if you say apply a role in your JavaScript to an element like our span earlier, you'll have to write something like, let's assume our button element, we've grabbed it and we're using button as a variable. So you'll have to do button.set attribute, open parens, quote role, close quote, comma, then the attribute value, so in this case, quote button, close quote, close parentheses, semicolon. And it's a little bit long-winded, and it's not how most people write JavaScript for other attributes in HTML. So what this phase 1 will do is let us write simpler code that's much more familiar and much more similar to the way we treat other attributes in HTML. You'll just be able to say button.role equals button. So it becomes simpler and much more familiar. Phase 1B will also let us set accessibility properties on elements when the element is first created in the page in the accessibility tree. But interestingly, they'll also let us change accessibility characteristics in response to user interaction. That's something that isn't possible at the moment. So when, for example, a user comes along and hits our button, in theory, with the AOM, what we'll be able to do is have the JavaScript listen for that button press, the same way we listen for key presses at the moment, and change the accessibility characteristics in response to that particular event. They're going to add some user events to make this more feasible, particularly on mobile platforms. So things that will let us do increment up, increment or decrement down. In swipe gestures, this is really hard at the moment. It's very hard to make that properly accessible if you're writing a custom element for use on mobile, because there aren't really any events, interaction events at the moment that equate to that. So they're going to add a few of these into it to make response to user interaction a lot easier and more straightforward. Then we get on to the slightly more interesting and perilous bits of the AOM. It will be possible to add things into the accessibility tree. So up until now, the browser is the only thing that can actually create or put things into the accessibility tree. With phase 3, this will all change. It'll be possible for us to come and add virtual nodes into the accessibility tree. On the one hand, part of me is incredibly excited by this, because I hate doing things like hiding text using CSS just to leave a little bit of helpful information for a screen reader user. Because I know that sooner or later someone who doesn't use my style sheets will come along and be presented with all that helpful information they really didn't need to see. So the idea of being able to add information into the accessibility tree just for the benefit of a screen reader user does have a certain appeal. I'm also curious about VR and accessibility. At the moment, VR on the web just operates inside the canvas element. If any of you ever explored Canvas when it was first released, all the visuals that appear on screen are just there in JavaScript. There are no elements other than the parent canvas element, and VR is very much the same. So one possibility of being able to add things to the accessibility tree is that we can create an accessible representation of the objects that are inside a web virtual reality. Now, I have no idea whether that would be feasible in practice, but the idea is an interesting one, and it's a possible use case for this part of the AOM. Lastly, the last phase will enable us as developers to walk the entire accessibility tree from top to bottom. So in the same way that we walk the DOM now to find out, give me a list of all the elements, all the anchor elements in a page, for example. With the accessibility tree walkthrough, we'll be able to do things like, give me all the elements on the page that are headings. And that will enable us to create functionality that will enable navigation by headings, for example. Now, screen readers do that pretty happily of their own accord at the moment, but keyboard users, for example, do not. So it opens up all kinds of possibilities for letting people navigate through content in different ways. We have to be aware, though, of laws of unintended consequences. And this is the one particular area where I think the AOM team really needs input from the rest of the world. There's a trade-off between accessibility and privacy. Once we make it possible for developers, for websites, for content to be able to interact and access the accessibility tree, we give website owners, content producers, with absolute clarity, the knowledge that the person using their website at that moment in time is a screen reader user. The reason it's that specific is because the browser only creates the accessibility tree when it knows an assistive technology is running. ARIA is only really supported by screen reader users, and the AOM is almost entirely based on the use of ARIA. So as soon as we start using it, we'll give away an incredibly personal level of information about the person consuming the content at the time. One school of thought at the moment is that the browsers can pop up a permissions notice. There's a bit of a trend at the moment with browsers to say, well, we'll just ask the user if they're okay with this and shovel all the responsibility onto the person who wants to use the website. And I can pretty much guarantee what will happen if this goes ahead. You'll get a little pop-up on the thing that says, this website would like to know that you are using a screen reader. This is being done in order to make this more accessible an experience for you. Is that okay? And of course, most people are going to go, sure. What they may not think about is that if there is advertising running in an iframe on that website, that iframe could be doing exactly the same thing. And we all know how trustworthy advertisers are with our personal information. So just imagine if you went to a website and because of an advert displayed in an iframe on that website that you largely ignored at the time, they grabbed information about you and says, hey, the person on the end of this IP address is actually blind or using a screen reader for another reason. And the next time you went back to that website, you suddenly started seeing all sorts of, quote, blind-oriented advertising for whatever anybody else might think that would look like. But that's a pretty dangerous territory to get into. And so we need to really think about the privacy question with the AOM before it gets too much further. It can't be stressed. It's one of those things that once we start down a path, we'll never be able to close it down again. So we've got to get it right the first time. And privacy, at least in my opinion, as a user and an engineer, is too much of a trade-off for the level of accessibility and return. But that's a conversation we all need to have. So that takes me to the end, and our need to be time travelers as we think about accessibility. There's an awful lot of accessibility information that we get from the past, from using HTML in the way it was first intended to be used. We shift a whole load of the heavy lifting onto the browser, the keyboard interaction, mouse interaction, a degree of visual rendering, but heaps and heaps of accessibility information that we don't have to do anything to provide. But we've got to recognize that we don't live in a world where we always have that luxury anymore. We do have to use JavaScript frameworks, often with good reason. They have plenty of beneficial things about them. Sometimes there just aren't things in HTML and we want to create them. That's fine too. We shouldn't constrain our imagination. And that's when we need to look to the present and using ARIA to understand what we need to polyfill in terms of accessibility. We also need to look at the implications as we start to see more and more web components and custom elements coming online to make sure that all the accessibility is baked in properly into them. And then lastly, we need to travel to the future, and we need to keep an eye on what's coming our way before it gets there, and we need to feed into that process so that by the time the future is here, we can be as sure as we can be that we've made all the right decisions, or at least made the best decisions that we can based on the information we've got available. So please, whatever else you take from this talk this evening, go away, be a time traveler in terms of accessibility. Pull the best from the past, the present, and the future. Thank you very much.